What's up? Sorry for being a bit late. I think I'm around 7 minutes late. But nonetheless, hopefully everyone is doing well. I can maybe close it. And today the plan is basically to do what I did yesterday. Starting with statistics and then doing some ODE. This one is turned off. No. Hello, Abdul. Man, my desk has like too many books and shit. Can I put it here? Hello, Gandalf. What are these streams about? I'm basically just gonna do mathematics and talk about mathematics. Yeah, that's what I'm doing. I want to slowly like transition out of study with me streams, since I don't really enjoy them that much. So yeah. I mean, I guess they're fine, and they have their own benefit, to me at least. I can just focus on actually studying, not really doing anything else. But I don't know. I also like doing these kinds of streams. 316 vertical laptop. Nice. I mean, I guess it is 360. True. But it's like not really, since you can't. Whatever. Like this. Okay, there we go. Yeah, feel free to join the Discord. I'll be having it over here. So yeah. Everyone is welcome to join. By the way, why do I have the stream elements bot in the chat? I don't want you here. I don't even use stream elements. Also, is Twitch going on? Yeah, follow me on Twitch. I'm also yesterday I started streaming on there. So yeah, I feel like these kinds of streams are more they're more suitable for Twitch. So part. Okay, goodbye bot. Consider to buy a graphics tablet like you. Can you tell me which one you have? I think this is the Huion Dial, like Q620 or something. It's an older model. I know there's a Huion Dial, like a newer model of the dial, and they're not that expensive. So it's I would say it's a good buy. I've had this tablet for around 5 years. I bought it 2019 during the winter, or I guess it's maybe 5.5 years. Like this. I'm like this. I'm not sure if you have watched Peacemaker, but the new intro song is so catchy. It's super catchy. I've been singing it in my head for the last couple hours. Will we be doing physics in the future streams? Maybe. I'll probably do that later, like in 2 months, to be honest. Also, I do want to check something. If I came in, if I got accepted into the physics courses. Let me just log in here. Right. Okay, I haven't responded yet. Okay. The silly mistakes in maths exam yesterday. Can you tell me how to avoid them? I mean, it's something that plagues me as well, but or I think everyone in general. But if you get good sleep and if you have time to actually soak in the material, usually it shouldn't happen that often, at least. I mean, I remember I did a math exam during high school, and I got like 4 hours of sleep. And and when I went through the exam with my teacher, there were literally mistakes everywhere. So good sleep is recommended. Can I study different subject in your stream, or am I violating the rules? There are no rules. But these are, I don't know if these are not like the study with me streams. I'll be talking and stuff, so maybe it's not really that nice to study whilst watching these streams. I don't know. Camera cool in the bottom. I mean, I tested it to be in the bottom, but I feel like I don't really know. I don't know if it matters that much. Anyways, we did Bayes' laws yesterday, or Bayes' theorem, which is a very weird theorem. I don't know. It's the proof is literally one line. It's weird calling it a theorem, I would say. We have a definition, and then it's a direct consequence. We just solve for one of the variables, or we use another theorem to prove it. But whatever. I don't know if this is some rigorous probability theory. I don't think so, but whatever. So you're studying the long hair question? Yes, the long hair question that I eventually got correct. Indeed. I struggle too much on that. I also get recommended a Veritasium video on Bayes' theorem, which I watched a little bit. I watched it a little bit, and it was interesting. I'm not sure if I understood it though. Yeah. And we did some independence of events. Yeah, so if events are independent, just to quiz myself a little, it shouldn't matter the conditional property. Oh, wait, what? I think... Yeah, by Bayes' theorem we have that this is the probability of I think, or should be B here. Wait, did I forget Bayes' theorem? What resource did you learn English? I learned it purely by online. I guess school, but mostly YouTube videos, to be fair. Yes, of course. So wait, how was this even done? So in the example, we had if the die is 5, given that the coin is tails. Wait, let me see my notes from yesterday. Let me see it. Teach English as a foreign language? I mean, yeah, English is taught in Swedish schools. I mean, you have English, Swedish, and then you can choose another language. Usually it's French, Spanish, or German. Those are the most popular ones. But you could do Russian as well. I know my brother did some Russian since I'm Russian as well. So, but I decided to do French during like middle school. In high school you can also choose, but English and Swedish are obligatory ones. Yeah, okay, wait. Yes, that's okay, yeah, okay, we have the definition. And we can use the definition to get Bayes' theorem. Okay. I guess that makes sense. Okay. Let me see if there were some exercises for this one as well. Favorite whiskey? I don't drink. Yeah, I don't drink. Alright, so we're at week. Okay, I guess there are no exercises there. Okay, let's do continuous probabilities. I think we'll just move on from this document. Suppose A1, A2 are a sequence of events that are getting closer. Okay. Then we might expect that the probabilities are getting closer to PA, i.e. that the limit but can we be sure about this? A sequence of events, that's interesting. So we have a I'm doing successive differentiation. Nice. Well, this is not really what I'm doing here. Properties is like this, which say that probability of AN is close to probability of PA when AN is close, are called continuity properties. The above question can thus be translated roughly as asking whether or not probability measure P are continuous. Oh, wait. Well, I guess, yeah. I guess I agree. So the question at hand is whether this is true. Given AN goes to A. Number theory next stream. I'm not currently studying number theory, so I'll do that. I'll be doing number theory in like maybe around 90 days in the second half of this semester. Possibly. I haven't decided 100% yet, so we'll see. But we'll be doing some measure theory. Or no, that's next semester, but at least some physics and some complex analysis will be like the topics. Let's see here. Okay, this is my kind of jam. I like me some continuity. Let us write that AN goes to A from above. I'm not sure if I really understand this notation, though. It increases to A. Okay, well, I guess, okay. Yeah, so AN, so it's just saying it goes from the positive end, right? We said a sequence. Oh, we define it. Oh, okay.
Oh, of course, they're not real numbers. Of course, we cannot treat them like that. Yes, we have sets instead of real numbers. That makes sense. The sequence of events is an increasing sequence. Is union is equal to A. For example, if we have this as a n increases, yeah, so this will decrease and this will increase, so the interval will be bigger, and the infinite union. Granted, I'm not sure if we need a union. Why do we need a union? You asked me what I'll do in my practical life. I wanna do some research. Like, why do we need to be like that? Can we just say that the limit, can we just say that this will have to go to infinity rather than saying that this has to go to infinity? I mean, I think they're equivalent. Yeah, they have to be equivalent since they're subsets. I'm pretty sure. Similar, that is right. Say sequence A and decreases to A if A1, indeed. So if we do the inverse, or no, that would, okay. Yeah, okay. Something says at several points in the text. For this, we need the following result. Suppose it increases or decreases, then the limit of this is this. Okay. See section 1.7 for the proof of this theorem. Can I prove it? By the way, is it visible? Yeah, so theorem 1.61. Oh. Can we prove it, guys? That is the question. Oh, okay. I'll just do it like this, maybe. Maybe this is confusing notation. Or A n decreases to A,
And then we need to show that the limit of Sn goes to infinity of the probability of A is equal to the probability of A. Alright, so let's recall definition. So let's assume or I guess we can just say assume An goes to this, i.e. we have that I'll just say for any k, if we increase the k's, it's like this. For any k for any index k. How many foreign students? There are a lot of foreign students in my program. They're like the majority. Probably. Or maybe not. Maybe it's like equal. But yeah, many people from Germany, some from India, some from the UK, etc. It's very diverse, I would say. Okay, so let's just increase this a little bit. It's actually kind of nice. I do enjoy the diversity, I have to say. Right, so this is a real number, right? So we can just do the epsilon definition. So we can let epsilon be greater than 0. And we can consider, I guess we can equally consider, okay, it doesn't matter, okay, yeah. So we show that we can find a delta or a capital N, such that when all n little n is greater than the capital N, we can make it arbitrarily close to this number, just applying the definition, if that makes sense. Does Lund Uni provide scholarships for international students? I am not sure, but probably. But most of the people that come here I haven't really met anyone that have gotten a scholarship, really. But if you're from the EU, it's free. So that's also a big reason why many people come here. It's cheap. It's fairly cheap for a good education. So yeah. As I understand it, if you're from the EU, most universities, like if you're from Switzerland or whatever, I know one guy from Switzerland, and you have to pay to get into, if you want to get into some university there. But if you can also go to Sweden and not pay, which is interesting way, like interesting. That you can do that actually works. That Sweden wants to pay foreign students to study here. I don't know. Nonetheless, okay, so are these independent events? Not really. So is there a way to combine these guys? So I'm not sure if this is the right way of doing it though. I've honestly forgotten all the rules of probability, like the algebra rules. I wanna look. Oh, this is chapter 2. Let's do this. Properties of probability models. Right, so if there are two events, oh, well, that's very convenient. Maybe, actually not, maybe not. I guess it could be convenient, right? These are A is a subset of this, so we can combine these guys. AN with the complement of A, which is interesting. Granted, I'm not sure where I'll go here. We need a term. We need an AN term somewhere. I mean, look, we can do some stuff maybe. So it's the complement of this. What is the complement of that? Alright, well, what I'm thinking is, I mean, this is equal to the complement of AN with this. Granted, I'm not sure if this will help me. Let's see, do I know the set rule? So it's the union, is union of, let's see. What book am I using? This is I haven't really what is the name of the book? Yeah, it's Rosenthal and Evans. Oh, you can't see. Science of Uncertainty. I'll just paste it here. I'm trying to do the proof of 6.1 or 1.6.1, and it's going interestingly. Wouldn't say it's going well. Maybe it's just easier than I actually think. This is equal to the probability of this. And this is the sum of the probabilities of each of the people. And this is equal to the limit as n goes to infinity of the partial sum of the probabilities. And what now? Okay. Well, this needs to be equal to the limit of P of a n. Granted, this only works if it's uncountably many events. Also update the description. What should I update? Okay, fixed. I don't know, does that happen all the time, the restream? The books? Yeah, right. Okay, well, I thought of something else. But I'm not sure if... do I even link books? You said no books, you are on summer break? I'm not on summer break, by the way. Let's see here. Probability of this is the union of is this just obvious? No, but this is, yeah. Okay, well, I guess it's not the. This is the same as the union. Union of the nth order blah 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 AK, and we know that this has to be equal to of an. And so we're done with the proof. So we don't even need to use the definition of epsilon, or like the definition of the limit. But I feel like I can do this more directly. What the heck? So this is the union of this. I can take out the limit. I can I think that's how you do it. Am I streaming study sessions again? Probably, but I want to focus on these kinds of stream nowadays. Which is different, and maybe I should do a post on it so people know what's up. Since yeah, I don't know. I feel like I kind of am bored with the normal streams, like with the Study With Me streams. Is this how they did the proof? No. No, they did not do it like this. But I feel like this is a better way, or am I doing something wrong? We want to prove da-da-da, arroband, da-da-da, then this is equal to this. Suppose this, we can write A as the A1 union. Right, they need to be disjoint events for you to be able to use the additive. Oh, is that... I see. Yes. Yeah, okay, so, okay, I did something wrong, but it wasn't really that big of a deal. Well, that's very satisfying. Okay, let's do it again. Okay, so we assume an goes above to A, and then we have this, which is the same by definition of this, of the union of these guys. Yes, I guess so. I still have some issues with this definition, but I guess it's fine. But I would define it a bit differently to make it easier, or to make it more obvious. But I guess it doesn't matter. Both mean the same thing. Like, I would rather say this is a limit of an as n goes to infinity, rather than the union of all them. But then how would you define the limit of sets? Let's see here. That's a good point. How would you define the union of sets? Or the limit of sets? Is that some topological stuff? Because we don't have any structure here. I have a feeling that this book is very unrigorous. Which I guess makes sense. It's an introductory book. What? Alright, well,
Okay, well, this could be written as the sum by the additive law, or I guess it is a law, since it's just a definition of this, where we have the probability of A, K, intersection A, wait, let me think. So we want was it like this? Or the complement of this, of course. I'm not sure if I agree though. -1. Do you even see Twitch chat? Oh, sorry, cheese and fries. You know, I'm very used to just looking at the Twitch or the YouTube chat. But yeah, thanks for joining. I think you are one of the first people joining the Twitch chat. Hopefully, yeah. I'll look at Restream. I'm using Restream to stream for on both YouTube and Twitch, but I found that it's not the best when it comes to previewing. But I guess I'll look on OBS instead. Right. Yeah, it makes sense. Okay, yeah. So the goal is we need disjoint sets. To use the additive law, we need to have disjoint sets. So what we're doing here is we're taking, for example, A2. So we're taking A3 intersection with A2, or the complement of, and this is negative. So it's A3 complement of this, which is this thing. And we know that these sets go in, so, or no, they actually go out. So we take this, and then for the next one, we take this. So these are all disjoint sets. Bada bing, bada boom. And then we can take the limit and we know that this is equal to the limit n goes to infinity of p of no wait this is the limit of the partial sum and this is same as the probability of an, which is
yeah, which is I guess you could prove it with induction maybe. I think a part of me wants to do it because I don't really do that. I usually just refer to induction, but I mean, and then we're done, but I want to do it just to be pedantic and okay, not really for pedantic reasons, but rather to convince myself that I know what I'm doing, which I guess is a good thing. Also, yeah, I want to see if I can set up a goal. I wasn't able to set up a goal yesterday of 1 super chat, and I'll do 100 push-ups if I reach the goal. Please work. Oh, it works. Okay, so you get 1 super chat. I'll do 100 push-ups. And if you have better ideas, comment them, and I think I can edit. Okay, I can remove the goal and redo the goal with another prompt if you have any better prompts. Yeah. So yeah. And on Twitch, I'm not sure if I can link them. Probably not. But I do have a follow goal there, so yeah. 100 push, 100 sit-ups, 100 pull-ups. No. Okay, that's you're no. That was the ultimate study challenge, and honestly, the 100 pull-ups is so difficult. But rather, I think for the ultimate study challenge, I did 200 push-ups, and I didn't do any sit-ups. I was joking, yeah, I know, but yeah, it reminded me of the challenge. I don't know if you watched it, but it's a short somewhere on YouTube, on the channel. Ay. All right, let's do base case, and then let's just move on. Or no, let's do base case, or let's prove it, and then move on. So the base case would be N1, right? And so we just need to show the wait, I'm dumb. Like this. So that we have, yeah, so we just need to show that P of 1, and this I just assume to be 0, or like I define no. Yeah, that's my cheeky definition. Anywho, well, that was easy. Let's do the induction case. And let's do that. Okay, I'll just use n. N plus 1, k1, p a k a k minus 1, c
p ak plus 1. I need to prove this. I'm not sure which way I should do it. I think it's just easy to do this. This is the same as p ak plus also I do a cheeky definition saying that if I do I do a n this is n is defined to be a n plus a n. Wait, I assume this is true for n, and yeah, so this should be plus 1, no? Wait, let me think for a moment. No, I don't do this. I don't do this. This is bad. P of it's supposed to be a n plus 1 a n c, and this is supposed to be p a n plus 1. Or no, wait, let's not do that. We know that these are disjoint, so an is intersection with a n plus 1 a n. This is equal to the empty sets. How to become math genius? Practice. It's all about practice. But I appreciate you calling me a math genius, but I certainly don't think so. Let's hear. But yeah, math is very fun. I really think it's a great activity to be good at. And that's also a reason why I also wanted to do these streams as well, just to show like it can be fun. You can enjoy yourself. It can be a social event. I don't know. Maybe I think popular media pictures math to be very isolated and a bunch of weirdos that don't know how to talk to people and stuff, which is partly true, but I feel like it's very collaborative. Maybe not as collaborative as other sciences like physics and stuff, which can have many co-authors in a paper, for example, many hundreds of authors. In maths, you usually never have that. But I found that math people are very keen to talking about math with other people, and you it's a very good way of learning as well. Opinion about person that want to switch his career from economics to mathematics, is it a good choice? You know, I know a guy, I'm not sure if I'll say his name,
but I like his name nonetheless. He is actually doing that. He's an economics major, and he's taking math courses like crazy. And yeah, so it's certainly possible, and in economics you do a lot of math, so it's not really a stretch at all. Let's move on. I mean, this is just obviously equal to... Okay, we're done. You can do it with deduction, and that's how you prove it. Okay, that works. Let's move on. Yeah. Okay, it was a very short chapter. Example: suppose S is a set of positive integers with P of S for all S, then what is the probability of... Okay, let's do this example and not read the solution. Book name, I'll just link it. I will link it. I did write it down further down the chat, but maybe you just joined, you can't see it, I'm not sure. So I'll have it in books. I think the book is fairly decent, not gonna lie. I can link all the books. ODE, I have this one, or this is actually for linear analysis. I'll link that as well. Fourier analysis. I have this one. And then for ODE, I have this one. Ordinary differential equations. Karl. Okay. Okay, so it should be changed in the description now. Okay, so the probability of 5 onwards. Can you use the theorem? Yeah, you can use the theorem. It's actually very nice. So if you define a sequence of events like this, blah blah blah, we have that this and we have that the intersection of these guys will be it will like diverge. I'm not sure if, okay, I think this is fine, but maybe I'll write down this instead. And we can refer to by theorem 1.6.1. So the probability of this is the same as the limit of the probability of each, yeah, of an S is an element, so it's just an integer. Yeah. Considering to switch my major, but I'm also realizing my country didn't support natural science and math that much, but right now I have a great curiosity about math. Oh, okay, what country are you from, Hiban? When it's possible you study in Cambridge? I mean, I'm currently in my second year, so in 2 years or 1.5 years, I'll get the opportunity to apply. So yeah. But I'll apply to many schools, not just Cambridge. I did also see that there is a school in Switzerland that's one of the most like top ranked universities in the world, like number 6 I think, and I had no idea that was that that was the thing. But yeah, so this is the same. We know that this has n terms, so we can just each of the terms has probability 2 minus s, so it's the sum of n terms of 2 minus s. But then again, they're not disjoint. I need to be a little careful. Or no, they are disjoint. Never mind. So it's n times 2 minus n. And we have exponential growth, which grows faster. ETH Zurich. Wait, isn't that Germany? Or I think it was ETH. Or no, I'm thinking of. I think that's, yeah, that was the university I was thinking about. Let's see here. Yeah, ETH. What was I thinking about? There was one in Germany as well. But this one is Switzerland, right? Yeah, okay. Yeah, granted, I'm not sure if they're what their position, like if they're good in maths, but they most likely have a master's program. So this should be 0. Let's see if my thing is correct. Maybe not. Okay, it's not correct. Okay, no, this is not correct. Yes, this is not correct. Yes, okay. So it's up to n, k is equal to 1. No, k is starting at 5, up to n, 2, negative k. So it's the sum of this. And we need to take the limit. And this, I mean, this is the geometric series. Okay, so it's yes. So let's do that. So it's the geometric series starting at this 1 over k. So if I want to use the formula, I do. So it starts at 0, right? So we have 1, 2, 0. So it's 1 plus 1, 4 plus 1. No. 1, 4 plus 1, 8 plus 1. Is this correct? So 0 to 4, and then we start at 5. Yeah, that seems correct. And then we add this, and this should be 1 minus 1/2. I think that's correct. If I remember the geometric series. So this is equal to 2. So we have 2 minus this. And this is equal to... Oh, shit, okay. Well, maybe this isn't that difficult, to be fair. This is just... So we have 1 plus 2 plus 4 plus 8 plus 16 divided by 16. 2 minus, this is 3, 3, 7, 7, 15, 15, 31. And this is 32, 16, no, minus 31, 16, which is 116. Oh, okay, that was nice. Okay, let's go to chapter 2. Random variables. How exciting. Okay. I think what is... So I missed a couple lectures. I missed yesterday's lecture, and that was regarding continuous random variables, and that is chapter 4, or section 4, 2.4. So if you can do maybe a bit of 2.5, I'll be very happy. ETH is top 10 hardest universities, or I don't know about hardest, but certainly the highest rated. I'm not sure if that's correlated with difficulty. Probably. I guess it's no coincidence that it's probably true. I think it was top 6 with one like this one rate ranking was top 6 at least. Okay, chapter 1 we discussed probability model as central object in studying in the theory of probability. This requires defining a probability measure P on a class of subset of a sample space. It turns out that there are simpler ways of presenting a particular probability assignment than this. Ways are much more convenient to work with than P. This chapter is concerned with definitions of random variables, distribution functions, probability functions, density functions, and the development of concepts necessary for carrying out calculation for a probability model using these entities. This chapter also discusses the concept of conditional distribution of one random variable given the values of others. Okay. Yeah. Top in mathematics and one of the alumni Albert Einstein. Oh. Wait, did he go there? Oh yeah, he did probably do that. That seems now familiar now that you're saying it. I think I read or like watched the video on where he went. Is it actually top in mathematics? I didn't know. Well, that's kind of exciting. Including something probability measure P. Once we have a probability model, we may define random variables for the probability model. Intuitive random variable assigns a numerical value to each possible outcome in a sample space. For example, if the sample space, then we might define a random variable x such that x is 3 if it rains. It's clear. Formally we have a random variable is a function from a sample space to the set R1 of real numbers. Bruh, I've never seen this. Who writes R1? Okay, whatever. Wait, is a probability function a type of like a probability function is a function from like from the sample space to 0, 1, and we're defining a random variable is just a function s to r. Okay, well, that's very broad, but I'm not sure if this book is very rigorous, not gonna lie. A very simple random variable, variable described above could be written formally as by. We now present further examples. The point is we can define random variables any way we like as long as they are functions from the sample space to R1. We might define a second random variable by saying this. If the sample space corresponds to flipping 3 different coins, then we could let x be the total number of heads showing. If there is exactly 1 head, otherwise, okay. especially every constant C is also a random variable by saying that one special kind of random variables if A is an event, then we can define an indicator function A written IA to be the random variable. So if S is an A, we have 1, otherwise we have 0. Okay. I guess that's fine. Consider rolling a fair dice. Let y be 3 more than the number showing. Okay. Okay. Then z of s is equal to, so y1 is 5. Okay. We write x is equal to y to mean, yes. Okay. Let x of s be s, and let y be x plus indicator 6. Okay, let's try to decipher. Okay, so so this is our event 6. So if we have rather, this would just be equal to s plus r6. Right, so this is equal to 1, 2, 3, 4, 5, 7 if sample space is 6, so on. Let's see if x is defined. Alright, bunch of notation. X is increasing without bound. Wait, let's see here. If this is an if x is defined to be the square, then we have that x is greater or equal to 1, but there is no large value of x because the value x is increases without a bound. We shall call such a random variable an unbounded random variable. Okay, thank you. To be functions of outcome s, and because it follows that the value of a random variable will itself be random. If x is a random variable, then what is the probability that x will be equal to some particular value x? Well, x precisely when the outcome s is chosen to be x of s is x. Continue for a random variable of example 2.1.1, and x is defined to be this. Suppose further that the probability measure p is such that p reign okay. Then clearly x is equal to 3 only when it rains. Thus, probability x is 3 is equal to rain is equal to 0.4. Okay, I guess that's fine. If b is any subset of real numbers, then p of x in b is equal to the s's in S such that x of s is b. Furthermore, to understand x well requires knowing the probabilities for different subset of s of b. That is the most motivational definition. If x is random variable, then the distribution of f(x) is the collection of probabilities. Wait, is p the probability? Oh, okay. All right. First, it is required that B be a Borel subset, which is a technical restriction from measure theory that need not concern us here. Any subset that we could ever write down is a Borel subset. Yeah, I remember my lecture mentioning this. Yeah, this book is not really... I guess maybe it's good to have a complementary book as well. I'm not sure if there is another book linked. So B can't be any subset. It needs to be a Borel subset, because I'm guessing there is some kind of contradiction if it's not a Borel subset. Which I faintly remember my lecturer mentioning. I have it in my notes somewhere. Somewhere here. For definition, if R that Let's just search what a Borel set is. So I'll just ask ChatGPT, to be honest. This is my strongest tool in my toolbox. What is a Borel? Is a set that can be formed from open intervals in the real line using the standard set operations. Formally, the collection of all such sets is called a Borel sigma algebra. Yes, usually denoted like that. Open sets are Borel, closed sets are Borel, since it's the complement of is a set can be formed from open intervals. Any countable sets, like the rationals, more complicated sets built from these via unit intersection and complements are also Borel. Essentially, the Borel sets are the smallest collection of subset that contains all open intervals and all closed under these operations. Wait. What? Okay. Let me think. Okay. You know, it sounds similar to like a topological space, but it's not. We need to have the concept of open, so it's just any set that is closed under the elementary set operations, and is built from open sets. Yes, yeah, I want an example of yes, non-Borel sets. Can I think of one? Before seeing the example, can I think of one? Is it like the Cantor set? No, but the Cantor set it's just simple intersection, right? Can I put this here? Can you guys give me an example? Are there any proficient math people in the chat? I was thinking. Let me just recall what the Cantor said, because I need to. So it's interval, and then we take the third. Yeah. So it's just but is it uncountable? Is that the question? It needs to be the countable. No, it doesn't. Okay, maybe I'm. Let's just read. Vitali set. Oh yeah, the Cantor set is non-Borel, I think. All normal sets we use in probability and linear analysis. Oh no, it is Borel, yeah. But they are very pathological that you never encounter them in applied mathematics. They mainly serve to show the limits of measure theory. The Vitali set. I haven't really studied that one. Start with the real line, define an equivalence relation. If x minus y is rational, each equivalence class contains all real numbers that differ by a rational number. Using the axiom of choice, select only one representative from each class. The resulting set is the Vitali set. Okay. Alright, let's move on. Can you set an example of a non-countable set with measure 0? I think so. Yeah. Studied the Lebesgue integral too. It'll help with the Dirichlet function, Thomas function, etc. It will help integrate the Dirichlet. I'm not sure what the Thomas function is though. But yeah, I think isn't it the Dirichlet function 1 if it's if you use the Lebesgue integral? I'm not sure. My friend told me this yesterday, but I forgot. Anywho, in figure 2.21, we provide a graphical representation how we can compute the distribution of a random variable. For a set B, we must find the elements in S such that let's see here. It's a collection of probabilities. So it's a set. For a set B, we must find the elements in S such that X is B. These elements are given by the set. Then we evaluate the probability. Yeah. Yeah, I know the Dirichlet function, but yeah. I'm not exactly sure what the answer would be, or like the integral. I think if the normal one would be 1, and if you flip it, it would be 0, no? Examples of non-Borel sets are very non-trivial. They just emphasize the importance of taking a suitable sigma algebra for an intuitive measure. Right. And a sigma algebra. Can I recall the definition of that? It didn't mention a sigma algebra. Studying stats 2. Nice. I don't know if I want to go in this rabbit hole though, but isn't it just closed? Isn't it 3 properties? And it's closed in union, intersection, and I actually don't know. Let's ask, what is the definition of a sigma algebra? Maybe I have the notes, to be fair. I probably have my notes. Lecture notes. So you need the Borel sigma algebra instead? Right. What was... Okay, so if okay, but what is the point? It's mathematics that lets us rigorously define unmeasurable sets, the sets for which probabilities make sense. Right, okay. So, and the Borel sigma algebra is the set in which distributions make sense. So it contains the SPSS sets, a collection F of subsets of S. X is called a sigma algebra if X is in F the complement of A. Alright. A is an element in F that is complement. Closed under countable union. Closure under uncountable or countable intersection. We define a probability space as a triple. So the sample space, the sigma algebra, and the probability. Alright, thanks AI. Okay, let's just move on. I don't want to get too bogged down. But it is an interesting topic. Maybe I want to actually read a bit more on that. But I first want to do these pages up to chapter 2.4 before I go on some crazy side quests. Thomae's function. 1/2 q if x is pq, where pq are coprime. PZ and Q in. I don't know if I've ever seen this function. Wait, what? So I'll call this Tillman's function. So it's 1Q if X is PQ. By the way, let's move down a little bit here. So PQ okay, so P is I'll just do this, and we have so it takes Yeah, it's just a real to real. Oh. Alright, let's pick a number 3/5. And it's okay. I guess 5/3 would also be a pick. But the larger we are, it goes like up here. And it's 0 otherwise. So it becomes smaller the more we go further out. And at 0 it's just 0, and the smallest prime is I mean, I guess 2/2 would make sense. So if 2 is here, it would be here from the negative side as well. Yes. Alright, I guess that makes sense. Never seen this function before, so it's kind of interesting. But there would be accountably many discontinuities. Oh, but isn't this Riemann integrable? Maybe not. Okay, I don't want to get too sidetracked, but this is an interesting function. But it seems like it would be Riemann integrable, since it only has countably many. It is Riemann, yeah, exactly, yeah. I mean, since if it's Riemann integrable, the set of discontinuities would be like the Lebesgue measure of the set of discontinuities is always has to be 0, and for an uncountably many for an uncountable or a countable set, the Lebesgue measure is always 0. So, all right, thanks Rishi for that one. That was interesting. I'll move this to the side. What course is this? This is statistics. So it's a it's called like basic course on statistics. It's the first statistics course that I'm taking. Yeah, for my math bachelor's. Very simple distribution. Consider once again the above random variable. Set, okay, so S is, so the sample size is range not clear, and wait, I'm thinking okay. And where x is defined by x rain is equal to 3, x snow is 6, x clear, and we have probability measure as well, probability rain, probability of snow, probability clear. What is the distribution of x? Okay, let's try to solve this first ourselves. So rain, snow, clear. So distribution of x, okay. So distribution of x is of all of s what was the definition? I feel I really can't internalize this definition. Collection of probabilities. Such that for what? Where x is... Okay, let's give an example of an element in the distribution. So given so distribution of x is equal probabilities such that okay, so the probability of x in the subset snow and rain, this would be equal to or snow or rain. Wait, no, that makes no sense. It has to be a real number. If it's between 2 and 4, it would be so that would just be rain. So essentially this is just a set of the probability of rain, set of all the probabilities x, where x is an element of the power set of S. Isn't this not the case? Hello, I'm back. Welcome, Chizo Fries. Welcome back. T of x is named after Karl Johannes Thomé. That sounds Swedish. Oh, German. Or Johannes is maybe German, eh? I know a lot of Swedish Johanneses, maybe. That's why, okay. Remember that random value is just a function from the sample space to the real numbers, and the then the probability is again just a mapping. Yeah. But I was a little confused, like but is this the case? Did you guess who I was? It's unfortunately just my Twitch username. I have no idea who you are. The name Cheese of Fries doesn't really ring a bell. Whatever you said about t was right. It's Riemann integral because rational numbers have measure 0. Yeah. And then 18. Is this correct? It seems like you have better. You know more than me. I don't know. Okay, let's just read the example. Jesus Christ, what am I doing? Well, if B is any subset of real numbers, then should count. Okay, I'm back from Twitch. Okay. Hello, James Grime. Welcome. I'm guessing you're Cheese of Fries. Hello, Clono Pin Commander. What's up? Okay, I guess, okay. Using indicator functions. Fantastic. Was just a random name. Nice. Background Twitch, it's cool. Yeah, I guess I don't know how it works, but there are some things that I enjoy. Like you can have alerts. Alerts are just built in, and yeah, that's pretty cool. But I don't really like how Twitch doesn't save. It doesn't save streams, which is not really that nice. What you wrote is correct. Good job. Yes. Nice. Well, if it is, I mean, this is a very, I don't like this definition. It gives it, I don't know, it's not nice. But this is also a kind of cool way of writing it, I guess. So if B is, let's see here. So if B is between 3 and 6, we would get 0.4 plus 0.15, and the distribution is just this would be an element of the distribution, so it is just the power set there. Good luck. Thanks, James Graham, for the donation. I now have to do 100 push-ups. Should I do it now? I guess I should. Okay. Should draw something called the cumulative distribution function. Maybe it can give you a little more intuition. Maybe it is here actually. Wait. I'll look into it. Oh yeah, I'll just search it. Or maybe I'll wait. Alright, well, let's do the 100 push-ups first. Maybe I'll read that a little bit later on, because I think this is a continuous distribution, or like you need like a continuous random variable or something. Uniquely identify the right continuous model to increase function. Or maybe not. But I think I'll study that later. Okay, I think, I'm not sure if I can do 100% off the rip. I'll do how many, I think I can do at least 40 without any breaks, but we'll see. Okay. Ay. Oh man, okay, that was 50. I need to take a little bit of a break before doing the rest. You don't need to apologize, James Grant. No, it's good. The stream has already gone on for like 2 hours. I need a bit of a break. Helped me understand the subject better when I first learned it. Probability is a pretty hard subject to start with, all because of all the rigor. You're doing very well. Thank you, NN18. Did you do like a bachelor's or something? In maths? Or what are you studying? Man, I'm so out of breath. I need to open the window as well. It's getting hot. Yesterday I went to Bridge again and so many people were math CS majors. Cool. Bridge is like the game, like the board game, or like the card game. Just finished my bachelor in data science and started my master's. Cool. Or in your last year. Well, good luck on you finishing your bachelor's, your thesis and everything. Alright. Can I do more push-ups? Maybe it was a bad idea to do like like as many as possible right off the go. Maybe I should have been more conservative. Okay, maybe I can do 20 more or something, maybe. Alright, that was at least 20. Alright. Oh man, I need some water. I'll be right back. These push-ups are killing me. Anyways, 30 left. That's not bad. right. There we go. Alright, still 30 push-ups left. I think I can do 30. I think so. To boost more your morale, thanks Anand for the... What is that for currency? What? I have no idea what currency that is. But nonetheless, thank you. All right, let's see if I can do 30. Oh man, I have like 7 more. I had a hard time with prob, at first with prob, but I ended up doing very prob-oriented research. Just need to get through all the annoying definitions and you're good. Noise. Yeah, I found the definition of distribution being kind of weird. I think you should have just defined it like this, how I did it. But yeah, I guess it doesn't really matter, but all right, I can do 7 now. There you go. That was 100 push-ups. Nice. Thanks again for James Grant for the donation. Appreciate it. Alright, let's try to continue. Example 2.23. Okay, we have probability. Consider a random variable y defined by this. What is the distribution of y? I guess it would just be wouldn't it just be the same? Okay, well, when y is 5, would, oh no, wait, it wouldn't be the same, no. When y is 5, or when y is, yeah, when y is 5, you would return rain and clear at the same time, and the probability of those is 0.55. So actually this set I defined here is not actually equivalent with I don't think so, with the definition. Distribution of x is the collection of probabilities. But in this case, in this specific case, they are equal, but in general, no. Since this would be, the distribution would be 0.4
you can have rain. Oh no, it's raining. Oh yeah, raining clear. Oh yeah. So it's impossible to get 0.4. You just have 0.5, 0.85, and 1, and 0. What Böiers showed that it is possible to track for all sources. They also indicate that it is rather cumbersome to do so. Fortunately, there are simpler functions available to help us track of probability distribution, including cumulative distribution functions. This is what you were mentioning in N18. I think so, right? Yeah. Simple functions to help us keep track of probability distributions, probability functions, and density functions. Okay. Well, there you go. Alright, what are the exercises here as well? I'll find exercises. La 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 la, la 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 la, yeah 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 yeah. There you go. All right. What is this? X round sigma algebra, a big measure. Ew. So my professor linked a book on measure theory. Donald J. Kahn. Can I not access it? Oh, I need to log in. Okay, 2.112. 2.23. Alright, let's do that. Just notice that your definition is not consistent. The actual definition is where B is the set of real numbers. Yeah, right. I did write down that definition, I think, somewhere. Right, let's see. But that's not written in the book, though. So it's the like the inverse image. So it's yeah. What is it called? I think it's just the pre-image, right? The pre-image of the set B, where B can be any set in R. For all B subset of R. Outcomes in the set B. Yes. Combination of events in the sample space which gives me a probability in set B. Yeah, so yeah, that makes sense. I'm not sure, like the definition, what like this definition is wrong. Yeah, and yeah, that is true. That's true. Let's see here. All right. Let's see here. 2.23 is the question visible? Yeah. Suppose we roll 2 fair dice and let y be the sum of those two numbers showing. So y, okay, given s, y is, okay, well, it's hard to write down. Compute, okay, it's not really important to write down. Y for every real. So probability of y being any real number. So right, so the probability measure would be the uniform probability thing. Okay, let me just write down the sample space at least a little so I don't get confused. Yeah, so it'd be 1, 1, 2, dot, dot. Then we have 2, 1, 2, 2, dot, dot, up to 6, 1, 6, 2, dot, 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 to 6, 6. And okay, yeah, right. So it's this, y is the sum of the two numbers. I mean, okay, first of all, y can only be a natural number. And I don't know why they say real number, because that makes no sense. Okay. I guess it doesn't matter. This is equal to can I write this with the indicator function? Let's see here. So y can be in the set guess it could be 2 up to 12. Because, yeah, that makes sense. And the probability of y in y written as indicator would be 2 if y is no, okay. 1 if it's I need to count how many I guess there is only one way of getting 2, but the probability of getting 3, I guess it's only one way. But getting 4, you could do it in different ways. How do I do this? Write it in a 6x6 grid. I guess that's pretty cool. Yeah, that you can do that. Yeah, that's better. But okay, so wait, let me see. What is the probability measure? Let's just write this down. I mean, obviously, if you do one die, it would be like 1/6, given any number. If you have 2 die or dice, I don't know why this feels weird. It shouldn't be weird. Alright, let's move this up. Okay. 136. If I have a 3, 1 to get 4, you can add 2 plus 2. You can do 1 plus 3, so it's 2. I 4. Bro, do I have to do this 12 times?
this could be done 1 plus 4, 2 plus 3. I guess that's it. I6, you can do it 3 plus 3, 2 plus 4, 1 plus 5, and that's basically it. Is there a more systematic way of doing this? I feel like there is a better way of doing this. If we add two numbers and we want to get a like 6, for example, and A and B are in 1 to 6. Let's see if there is a better way of doing this. I feel like there is a better way of doing this. What is the next one? Write a formula for probability of y in b for any subset b of real numbers. Let's see here. So y could be from 2 to 12 for any other real number. Yeah, so it just counts them. Okay, well, that's exactly what I was doing, but okay. Probably there is a systematic way of doing this, but I can't figure it out. Or I guess I can, but I can't bother. Give it enough prep time. Now for any subsets. Okay, let's see. B, Y of B. Alright, let's just do this properly. I think we need to write down the function first. Yeah. So you can do 6, 1, you can do 4, 3, you can do 2, 5.
Let's see. So 7, 1, 6, 2, 5, 3, 4, and I think that's it. B36, get 4. Yeah, so I8 would have 2, 7, 2, 6, 3, 4, and I guess you would have probably that's it. And I think that's. Oh wait, we have even more outcomes. Oh, okay. If you write it down with order, it would be more. Probability mass function. Okay. Okay, so it's symmetric around. Wait, is it though? Yeah, you would have 4, 4 as well. This is not even true. Wait, 4, 5, and this would be 4, 4. Yes. How would you write it down when it's a subset B? Well, I guess it would be the same, no? Yeah, it would be the same. You can do it with indicator. Yeah, since there isn't, or maybe there is a solution, but I'll just add ChatGPT. For problem B, what is the general form of P? Y in B in the subset? Yeah, I'm pretty sure that using indicators like this is how you do it. Ay, let's move on. Okay, let's move to sugar discrete distributions. Cool.
all of the probability associated with the random variable. This can be found from the probability that x will be equal to certain particular values. Okay, maybe I'll take a break here before moving on to chapter 2.3. And then probably I'll do up until 2.5, including questions and stuff, and then move on to ODE. Because my brain is feeling a bit fried. It has gone around 3 hours now. So yeah, I'll be probably having some lunch or whatever, or rather some dinner, and then I'll just continue the stream. Yeah, so I'll just be AFK. I won't end the stream or anything like that. Maybe I'll just do like a disclosure. For end stream, yeah, I won't end stream regime. You can Wikipedia, it has nice proofs of its continuity and differentiability. Domains function. By the way, Rishi, are you in high school or what are you? It seems. If you are in high school, it seems for a high school to say that a function has a nice proof for its continuity is very unique, in a good way, of course, in all the best ways. Right. Oh. Holy shit, that looks insane. Someone actually plotted it. How is my plot compared? It's actually pretty close. Not really. I for some reason thought of it as being exponentially increasing exponentially, which makes no sense because it's just linear. So it has to be straight. Right? It's like a harmonic thing, I think. Or maybe I'm wrong. Yeah, actually, why is it straight? Whatever. Nice. You know, this is probably I have students that for one variable, I wanna mention this function. This seems like a cool function. I've never seen this. I'm probably none of the first year students have also seen this. The popcorn function. Nice. Anywho, yeah. I'm thinking of also downloading Linux. What do you say? I'm a little scared though. I recommend doing Ubuntu first, because you get the upsides of getting used to the terminal, using the terminal, and also you have a lot of pre-installed stuff, which is very convenient. And then you can move on to Linux, and also you can dual boot. In that way, you can just go back to Windows if you want to, and you can do that for any PC or laptop. Or if you have a PC, you can buy a new hard drive. I guess I've heard there are some compatibility issues if you have if you dual boot, but I've never experienced it. So yeah, that's at least how I did it. I did do dual boot first. I downloaded Ubuntu and then went to Arch Linux on my PC. Granted, my setup is not good. On Arch, it takes a lot of configuring, and that's just the inherent property of using Arch Linux. So if you like configuring and tinkering, you can do it. Or like it's probably something that you would enjoy. What is the expected value of random variable? Okay. Okay, nice question, and then anything. Random variable. Okay, I wanna solve that one when I come back from dinner. Okay, I'll be back in like maybe 30 minutes max. Okay. Wait, let me actually first do. La 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 yeah. All right. Diner break. I think I was out for a bit more than 30 minutes, but whatever, around 30 minutes. So yeah, you wrote R as the range of T on your whiteboard. However, I guess you can write, or what do you mean? For all Q is included because T has so range would be. Well, I didn't write the range. I wrote the codomain. Yeah, but otherwise it's correct. It's between 0 1. Yeah. But yeah, it's from R to R, and yeah, 0 1 is a subset, so it works out well. You know, I was talking recently to a friend, like, what is the point of a codomain? And my friend answered that the point is to have mathematical freedom. So in this case, you just have do the most general set, which is R. Anyways, my brother's wedding. You're starting with Darin. All right, cool. Well, congrats to your brother getting married. Oh, I was lurking while you had the last problem of 1.3.2b, or maybe 1.2.2b, which asked for p, y, and b, and it says let me know if you got p, y, and b, the sum. Whoa, what is that? The characteristic function on B. Something like that. Anyways, well, I said that I might be wrong then. See if it works if I'm not here. Oh. I think that was 1.3.2b. Oh, okay, yeah. I'm not really sure with the question there. Did I do it today? Or do you mean 2.3 point? I think you mean 2, because we haven't done 1.3.2. We did this one. I'm not sure what you mean by the characteristic function on B. Nilenko. No differentiability everywhere. All right. Well, I guess I'll just move on. I'm not exactly sure the answer there from you, Nilenko. Still on statistics. So we're on discrete distributions. By the way, is the audio good? I think so. Yeah. Okay, let's just move on. Cool. So x discrete if I'm not sure if I understand this. This means that there is a positive for many random variables x. We have that the probability of x being some value is greater than 0 for certain x. This means that there is a positive probability that the variable will be equal to certain particular values. With some certain particular values, then all probability associated with the random value can be found from the probability that x will be equal to certain particular values. This prompts the following definition. A random variable x is discrete if at first glance one might expect 2.3.1 to be true for any random variable. Let's see here. Okay, so x is a specific value, so we don't have b as a so we don't have subsets of the sample space, but rather specific values, and we need the sum of each of these. So this is like an uncountably large sum, which is interesting. I've never written a sum like this. Let's just try to understand this. So it's like so it's a sum from infinity like that. But it's also x can also be real, so this is a weird. Okay, so it's not really a normal sum. It's just like a. Okay. Definition says that the amount of values the variable x can take with probability positive, with positive probability, is countable. The TX proofs? No, I'm not gonna do that. Yeah, I don't wanna allocate too much brain power into that because I know I'm already like my energy is slowly dipping, so I want to focus on the things that are relevant. So yeah. Alright, 2.3.1 does not hold for the uniform distribution or for any other continuous distributions, as we shall see. Random variables satisfying 2.3.1 are simple in some sense, but we can understand them completely just by understanding their probabilities of being equal to particular values, instead of indeed by simply listing out all the possible values x. The amount of values the variable x can take. Is it true in an 18? Okay, here we go. Because Andersson completely by understanding their probability of being equal to particular values x. And by simply listing out all possible values x such that it's positive, we obtain equivalent definition. A random variable x is true if there is a finite or countable sequence x1, x2 of distinct real numbers and corresponding sequence p1 of non-negative real numbers, such that distinction between continuous and discrete random values heavily measure theoretic. When I first studied stat, it was good to just take this as granted. Okay. All right. I don't really see the equivalence here. I mean, because this is a sum of uncountably many terms, right? And we so how do we corresponding sequence? Okay, I'll just move on. This second definition also just how to keep track of discrete distribution. It prompts the following definition. For discrete random variable x, its probability function is the function px from Owen defined, yeah. In a probability function, but only if we know that x is a discrete random variable. Finally, we know that theorem 1.15.1 immediately implies the following: law of total probability, discrete random variable version, discrete random variable, and let 2.3.1. So the probability of A let's just write this down. But the amount of elements that are non-zero in the sum is countable. But why? Why can't it be uncountable? Uncountably many. Is there a problem with that? Let's see here. This is getting a bit difficult, not gonna lie. Okay. So we have a conditional probability here. So this is any x, so that this, and where x is it's the element from the subspace, and or I guess it could be 8 subs as well. Okay. Low total probability. Okay, let's view theorem 1.5.1. From definition 2.3.2, we have that the sum over only the distinct given is already 1. So for all other values, it must be 0 from the properties of the probability function. Yeah, that makes sense. Like if you base it from definition 2.3.2, but if you just, how do you go from 2.3.1 to 2.3.2? Like how are they equivalent? If we start from this one, how do we conclude that only a countably many number, you know, x1, x2 has a probability greater than like a positive probability? Means that there is positive probability that the variable will be equal to 0. So it's just an assumption. I assume otherwise then you get infinity. Refer from probability that x will be equal to 0. Okay, I'll just move on and see if it clicks later on. Oh yeah, I want to see the law of total probability. I think I forgot that one. Okay, so it's just this one, and you can, okay, gotcha. So if you have yeah, for any events okay, yeah, so the law of total probability, I'll just write it down here.
And you can do the conditional version where we know that the conditional of this is equal to of this, right? And we can just solve for this one, so we get P A1 union B oh yeah, right. So I guess we can choose if it's B or A, or it doesn't even matter. Oh, never mind. I'm blundering big time. And so on. And here we can rewrite it using what? So if you have a discrete okay. Intuition is good. If you sum over uncountable positive numbers, you get infinity. So there must be only a countable number of elements for which it is non-zero. Is it true? If you sum over uncountably many positive numbers, you get infinity always? I actually don't know that. So there must be only a countable number of positive elements. What is the proof of that? You assume otherwise? Maybe contradiction? Well, if that is true, it certainly should make sense, right? Yes, then, okay, well, yeah, okay, well, yeah. Do you know the proof of that? Let's state that I'll ask ChatGPT for some guidance. I mean, usually you just sum. It's just weird, like if you have an infinite series, for example. I mean, you're summing a countably many terms. Yeah, what does even sum mean in this case? Under the standard definition of uncountable sum, any family of non-negative reals has sum. For an index I, okay, so it can be uncountable and numbers. Oh yeah, so here's how we define it. We'll look at all finite partial sums. Where do you study this? Is this like a measure theory course, or I've never even thought about this, if I'm completely honest. Summing and uncountably many things. Is this some measure theory stuff, or some, I don't know. What does finite even mean here? Like, what does that mean? All finite partial sums. Okay, well, so all, okay, so it's even, okay. First, calculating probability 1, we were talking about definitions, but only really dove into it in measure theory course. Okay, I see. Alright, well, I think I'll just save my energy and not dive into it too much. And instead just move on, because there is a lot more to cover today for me. At least we haven't even started on ODE. What's this?
Do I know the proof? How do you prove this? I don't think I ever saw the definition of uncountable sum, because they are either infinite or they have uncountably many non-zero elements, and as such can be written as regular sums. But why is it infinite? Like for normal like what I'm wondering is why can't it just be another number? Like the series like this, if I remember correctly, it's like some finite value. Why can't it be a finite value? For uncountable sets. Or are you just assuming it's infinite, or is it just some obvious deduction thing? Let's see here. So we can do probability of A1. Maybe just switch it there. So A1 we have. So this is equal to probability of BA1, probability of A1 plus probability of BA2. And if we have we can view this as the sum of the probability of x being x times the probability of b x being x. And I guess that's it, but okay. The direction of the proof that the chat gave is correct. You can bound the sum from below by taking only small sum of the values, but the bound still goes to infinity. Honestly, I didn't even look at this. I was okay. There is uncountably many positive terms. Therefore, there exists. Oh yes, okay. Okay, for each n in the set j and I, where ai is it's a subset of that union. Okay, it doesn't seem obvious for me at least. Direction of the proof that the check gave. Oh, yeah, I already read that. Okay, well, I'm happy with this deduction of theorem 2.3.1. So let's just move on there. Degenerate distributions. Certain particular discrete distributions are so important that we list them here. C is always equal to a particular value. It's probably one distribution of C is called a point mass or point distribution or degenerate distribution. Actually, a coin the probability data of coming up heads. Wait, what was the definition here? Right, so we defined okay, I guess that's fine. Said to have the Bernoulli theta distribution. You write this as random value of x is said to have the Bernoulli theta distribution.
Have I some lecture notes? I think this was, yeah, this was mentioned in the lecture. Yeah, discrete random variables. Oh, okay. So this px is the probability mass function apparently. A probability mass function is a function such that yeah, okay. Yeah, so in the lecture notes they did define for a discrete variable, they did use definition 2.3.2. Okay. So x is a Bernoulli called a Bernoulli distribution random variable on a Bernoulli if x takes value 0, 1, ew. Wait, what is the definition of a Bernoulli? Is it just when x when our random variable outputs 0 or 1, or like two real numbers? So if this is equal to when will I start ODE? Probably soon. I'm starting to get a bit tired, so I'll probably do it maybe after this example, or there will be a lot of examples, granted. Yeah, we have the geometric, the binomial distribution as well, a negative binomial, and Poisson as well. Hypergeometric as well, what the heck? We have children outside. If a discrete random variable x outputs either 0 or 1, do we call the distribution a Bernoulli distribution? That's exactly a Bernoulli distribution. That takes value 0, 1 with probability p, 1 minus p. Is said to follow Bernoulli distribution with parameter p. So does the probability have to be p and 1 minus p? I mean, I guess so. Blah 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 blah. Yeah, okay. Wait, let me just think. Wait. Oh, it's just a consequence, obviously. Yeah, it has to be a consequence. Yeah. So if the random value has output 0 and 1, the probability function has to be, yeah, okay, let's write that down. Thus, the probability mass function of this random variable needs to be, okay, given 1, it has to be p, and given 0, it has to be 1 minus p. And let's because then the sum of all the let's see. I was thinking, so we need to have that the sum of all elements need to be 1. For I something. And if this is true, then we automatically get that this has to be 0, which makes sense. I think that makes sense. Yep. Okay, so an example of this is a coin toss. So the sample space is heads or tails, and I guess we can assign a random variable. Okay, arise. Anytime we have a response variable that only takes 2 possible values, and we label one of these outcomes as 1. For example, 1 could correspond to success and 0 to failure of some quality test applied to an item produced in a manufacturing process. In this case, theta is the proportion of manufactured items that will pass the test. Alternatively, we could wait. Yeah, so we need to define p as well. So it's a value between 0 and 1. Manufactured items will pass the test. Alternatively, we could be randomly selecting an individual from a population and recording a 1 when the individual is female and 0 if the individual is male. In this case, theta is the proportion of females in the population.
You have students for calculus of one variables when you were commenting on TX. Yeah, so I have I'm hired by the university to do to have exercise classes. So basically for first year students doing one variable and algebra and vector geometry, which are 2 courses that you do the first semester. I basically help out 2 times a week with homework they have and stuff. And I was thinking the function you mentioned was a good example if you want to give. I remember. I guess the wire stress is a good one that is continuous and not differentiable. Granted, was the T one continuous? Or it's obviously not continuous, but or maybe actually now that I think about it, what are the properties? Because it is a Riemann and stuff. Maybe it could just be a test, when going through Riemann integration and stuff, because it's not intuitively Riemann integrable, I would say. Anywho, or it could be a fun function to prove differentiability or something. Granted, I haven't looked at it, but yeah. Okay, I think we'll do one more example of distributions, and then we'll move on to ODE. All right, binomial distribution. And coins. Again, 0 to theta. Okay. Let x be the total number of heads showing. Okay. Let x be the total number of hits showing by 1.4.2. See that for x0 to n. That's what is 1.4.2? So we have this is this is this. But I think they won't understand the function itself because it is in the form of an infinite series with a few conditions. Tx is simpler because it's only based on rational numbers. Yeah, I myself am not really sure the definition of the Weierstrass function, but I remember it was a example in one variable of a continuous but non-differentiable function. But yeah. Okay, I'm not really sure about this one, but I think I'll just end it here with stats and just move on to ODE. So I have time to actually do some stuff there as well. I don't know where I'll put. Maybe I'll just put it there. Yeah, what is the wire? So. Let's see. Oh, it's defined as a Fourier series. Oh. With the form, well, the defined differential has a defined differential on every value of x that can be expressed in the form. The function has no finite differential at x, corresponding to completing the problem of differentiability. Oh shit. Okay, that's, yeah. I sent a proof of the uncountable sum in the Math Calc Advanced chat in Discord. Let's check it out. Wait. Where is this? Did you write this up? Nice work. Nice, nice, nice. Nice. The collection of positive real numbers. Okay, we're summing over possibly less positive numbers, and so we have that says here that this is less than, thus E has at most many elements. Ooh, wait. Such the union is countable as a countable union of finite sets. Oh yeah, we assume it's finite. Okay. Okay, and then you show that the union is I. Yeah, which makes sense since this goes to 0, as AI also mentioned. Okay. So this would be an equality here, right? By this thing. Wait, this inequality, I'm not really. Let's see. So we know that each is less than this. So all elements of this. Okay, well, yeah, so we know each, this is less than. Or no, it wouldn't be an equality there, since we're not doing the union. Only finite elements participating in the sum, which is not what we have. Yeah. Wait. So here you're doing a union of. I mean, I think it's worth mentioning what even. Oh, okay. I guess yeah, this would be a countably large set. Yeah. Okay. Okay. Okay, it's interesting. All right. Well. Yeah. Thanks for writing it up. I'm not sure. Probably it's a similar argument that AI gave here. But yeah. Instead, he gave instead of 1/n, he gave this 1/2 to the n, which is fine. Both are fine, I guess.
if each Jn is finite, then the right hand side could be countable union of finite sets, hence countable, contradicting that. Yeah. Therefore, there must then Jn is infinite, in fact at least countable infinite. Yeah, this is exactly the inequality you had. Okay. Interesting. I don't want to spend too much time on this though, which I maybe already have done. Anywho, let's move on. Where was I yesterday? Right. I wanted to do the questions on chapter 1. Yes, okay, I remember. Oh man, yesterday I started chapter 1.2, and then I read this and was like, yeah, I feel good, and then I came to this sentence, and then I think I spent around 90 minutes on this. I think I went back, yeah, specifically. Yes. So we showed that the linear ODE of order n is always Lipschitz in a compact interval inside I, where I is where, wait, let's see. Yeah, where I is the interval where the matrix A and B are continuous. And in this text we show that it's Lipschitz in all compact intervals, therefore it's Lipschitz in the entire interval I, which was not very convincing. And to be fair, it's still not very convincing. But I want to go through the proof of the maximal solution theorem, and then it should make sense, hopefully. Oh, yeah, let's open this one. Or yeah, these were the examples. Okay, maybe I should just go back and see if I understand these theorems. I think that's just the best thing to do. Yeah, I'll just go back to chapter 1 here, just to have a good foundation, because granted I haven't really read these pages that thoroughly. Alright, before I do that, I need to go to the bathroom.
probably tackle uncountable sums in Fourier analysis, where they will show it only makes sense if the amount of non-zero element is countable. Interesting. Okay. Well, yeah. In the course I'm taking, we haven't really said the word Fourier yet, even though it's a course on Fourier analysis. But yeah, yeah, looking forward to it. Yeah. Okay, I think here is where we were. Okay, let's actually continue now. Generous resort to proxy solution. However, before you said about doing things, this you should make. Is that all? Even if the differential equation you work with originates in some real situation, you always make some approximations when you derive the equation. Interesting. There's always a general existence theorem. Okay, so it's continuous function from some open connected set. Is uniquely determined, can be written that this is the case is in no way self-evident. Yes, I remember this. Okay. Okay, I think I remember this well. Okay.
in the case where n is the inequality in 5, can be determined geometrically in the following way: the curve lies in two sectors bounded by the lines. By passing to the limit, we obtain corresponding equality for solutions. Geometrically, this inequality makes good sense, to be sure, from the differential equations. So if the solution curve has an absolute value not exceeding b. Yeah, exactly. It is clear that the solution is defined in at least interval. From theorem 1 can therefore be stated somewhat more precisely. The solution condition in R where beta is the sub of, yes, initial value problem 1 has a unique solution defined in the interval yes. Initial value problem. Oh. Concrete situation. Okay, yeah, let's do some examples. Example 4. Okay. Show that this with initial value this is defined in t less than or equal to 1/2 and satisfies okay. Okay. Wait, why is there white? Why is this white here? Whatever. Okay. So if the function f of x of t, or rather let's do t of x, which we define to be x squared plus cos square of t, is Lipschitz on an interval around 0, so alpha naught x less than or equal to beta, then, and it's obviously continuous, then unique solution on t less than or equal to alpha, which is the sup of alpha naught and sup, okay, and capital B beta, where B is equal to the supremum of x squared plus cosine 2 of t. Yeah. Pretty good study session. Alright, thanks NN18. Wish you a good rest of your day. Yeah, it was nice having you here. See you. Alrighty. There you go. Okay, so defining alpha to be the supremum of alpha naught and beta divided by capital beta is good, since then we don't get that the solution curve escapes vertically in the rectangle, which we define to be R naught. So this is our rectangle, and can I highlight this? Nice. Yeah. And why is it bad that it escapes vertically? Well, if we have a rectangle and our curve escapes vertically, then it's not Lipschitz in that curve. Do I know about trigonometry? I know a little trigonometry, but I am the worst guy when it comes to remembering the functions, or like the identities and stuff. Anywho, yeah, so it's bad if it's escaped vertically, if the solution curve escapes vertically, because it's not Lipschitz, it cannot be Lipschitz. Or rather, it can be Lipschitz, but the convenience of having beta as our Lipschitz constants disappears. I think that's how you reason. Probably, mayhaps. Honestly, I feel like I should do another goal. Should I set another goal? Start another goal. Okay, if I get another super shot within an hour, maybe. What will I do? I guess I'll do another 100 push-ups. If you have any other better suggestions, please let me know. Whoa, what is going on there? One super chat. Alright. That sinus, cosine, and tangent, cotangent, they are so hard. I think you'll get it eventually, Simi. Yeah. If you know your unit circle. All right. Let's see here. Gonna come to streams when I'm working, alright. You're very much welcome to do so. Yeah, feel free to join the Discord as well if you want to be there. You're always welcome. Is it where x is less than beta? I think. Granted, I'm not really sure about this. How do I solve this problem? Okay, so given this, okay, what is the solution here? It's continuously differentiable, hence it satisfies the Lipschitz condition in it's rather the biggest value of or not. Okay. We say b sup r x squared plus this is less than all right. Right. the solution is defined on the minimum of this, which is 1/2, and satisfies xt is less than or equal to 2, so of t is less than 1 there. Right, yeah. Okay. Okay, let's try to redo that on my own. This is not intuitive for me at all. Okay, let's see here. This is not intuitive. Okay. So we have that if f of t of x is c1, then on some interval, which I say is I, then f prime, or no, then f is Lipschitz on I. And I is a subset of R, like this. Let me just think. It should make sense, but I think, yeah, it cannot just only be like this. It needs to be bounded as well. If this is C1 and bounded, we can just reason purely geometrically. Since I guess this one is, or maybe I can just do the tangent function. Oh my gosh, can I draw? Given interval, maybe pi half, negative pi half. Tangent function is continuous there, it's differentiable there, so, and it's derivative is continuous. So it's C1 in that interval, and but it's not bounded there, so we cannot have Lipschitz continuity there. Yeah, exactly. So it needs to be bounded. Okay. And here we see that hold up. Oh yes, of course. Yes. Right, so if f is continuous, we just need to make sure that we pick a bounded a compact interval, and then we can pick a biggest and smallest value there. So that surely makes sense. So that's why it's omitted in the solution here. Sure. Okay. Let's just do the derivative of this with respect to d, I guess. And let me just think for a moment. Yeah, so we need to, I mean, if we really want to check if it's C1, we need to make sure that both partials are continuous, and that's obvious, since it's just a composition of elementary functions, which means it's continuous. Yeah. Yeah, I mean, it's C1 and given a compact interval, so we need to check, or actually we don't need to check anything. We know now. So okay, so alpha is equal to beta, or is equal to 1 supremum of this of x2 plus cosine of t squared. And this is the biggest when both are the biggest. So when x squared is the biggest is when it's 1, and when cosine is biggest is when it's 1, like this. So this is equal to 2. Or rather 1/2. Oh wait, that's not really correct. It's alpha naught, which is equal to 1/2. So alpha is equal to this, and it's the sub, or rather the max of this, which is just equal to 1/2. Therefore, the initial value problem x prime is equal to x squared plus cosine square x0, 0 has unique solution. In R yeah. Let's see the theorem. The initial value problem 1 has a unique solution actually defined in this. Oh, yes, of course. I always struggle with, given we rewrite ODEs as vector fields, but the solution itself is not a vector field, it's rather just a function R to R. So it's a unique solution in interval only in t. In interval in t less than alpha or less than 1/2, which implies that x of t, which we know grows, has upper bound b, which is equal to 2, and this is less than or equal to 1/2 at most, so this is equal to 1. So it's bounded by 1 always. In this interval, it satisfies inequality 6. Yeah. In particular, x of t minus x naught is less than or equal to beta. There. Yeah, it needs to be absolute value there. All right. Cool. And this is the problem we did yesterday. Domain of solution depends on initial value. Okay, maximal solutions.
assume that a function f is defined and continues in an open connected set, and satisfy Lipschitz condition in a neighborhood of every point there. Consider again the initial value problem 1 by theorem. By theorem 1 there is an interval. Okay. It's continuous in an open connected set and satisfy Lipschitz condition in a neighborhood of every point there. There is an interval around t0 in which we have a unique solution. Around t0 in which we have a unique solution. Follow the solution curve to the right a little bit at some point, to some point t1 near. We can use this theorem again with t1, x of t1 as initial point. In this way we obtain a continuation of the solution curve to the right. This is the thing that I'm not really convinced about. Like if you have a point t0, x0, and we know it's Lipschitz in some neighborhood here. There is some solution curve. If we pick this to be our new point, x1, t1, we can apply the theorem again. Or no, wait. Wait. Am I thinking about this wrong? Maybe this would be our point. We know there's a neighborhood here. Some neighborhood. Okay. Where with Lipschitz and stuff. And then we can find an interval where there is a solution there. Okay. So we can define this, for example. And this is our interval. So apparently we can extend this. Okay. Okay. I mean, can we cover the interval with open neighborhoods? I'm not fully convinced. Yeah. Let's just read. We have a unique solution. Follow the solution curve to the right a little bit to some point t1 near t0 plus alpha. Here we can use theorem 1.1 prime again with t1 x of t1 as initial point. In this way we obtain a continuation of the solution curve to the right. Put alpha to be the supreme of t0 solution curve can be continued to the interval. What's the solution of a problem 7? Okay. Let f in the initial variable problem 1 be defined and continues in several elliptic condition in the neighborhood of every point there. Define a1 and a2 as above and let k denote a compact subset of omega. For the maximal solution x of t of 1. The point is a sort of k if t is close enough to a1 or a2. This means that when t comes close to a1 in one of the following cases,
Alright, let's argue with AI. Let's do it. When finding the maximal solution, then you get a new neighborhood. I mean, do you do it uncountably many times? Like, I guess. To eventually get a unique solution. Let me see. You pick a point near does this point lie to the left or to the right of the initial interval t minus t naught less than LA, or does this matter? Then you get a neighborhood which you do uncountably many. Then you get a new neighborhood which you repeat uncountably many times to eventually get a unique solution that runs through the entire interval I. Let's see if we can give some insight to my argument. I feel like my argument is not the best. I'm not sure if the new point you need to pick needs to be to the left or to the right of the initial interval. Intuitively, I think it's to the left, but then I'm not really sure. What's my ChatGPT plan? My plan, I think it's just like the normal plan. It costs like 20 euro, or yeah, 20 euros per month. It's fairly expensive, but I think it's very convenient and stuff like that. Okie dokie. There is a unique solution on some small interval. There is a unique solution. Okay. The idea is once you've solved the equation, you can take a new point you want in that interval. For example, okay, with corresponding solution value. Yeah. Now treat this as the initial point. The theorem gives you existence and solution around T1 on an interval exactly alpha 1. The interval will overlap with the original one. Yeah. And by uniqueness, the two solutions agree where they overlap. Yeah. This way you patch together solutions to extend further in time. It doesn't matter whether you move to the left or right of the original interval. No, that's not what I meant. Okay, I guess my other question is, how do you know that the new interval you are given by the theorem will extend the first interval T0 minus a T0 plus a. Couldn't it just be a smaller one? A subinterval. And why couldn't all points in the interval be sub? Oh, well, I mean, I guess if you do the boundaries, wait, what? Once you've solved the equation on, you can make a new point. Well, nah, this doesn't make sense to me.
Oh man, this is okay, well, I mean, maybe. I'm just still trying to understand this. I guess if you have an interval like this, and then you pick the boundary, for example, and then you get another one. We can reiterate and put and we can move to the left as well. Put if we define it in the boundary, I guess we can extend it, and I guess we extend it by some small. We'll just call it alpha. This could be alpha 1, and this could be like alpha naught, and then this point is our t naught. I mean, the question isn't like, I mean, the question is how can we make sure that the alpha, like the radius incretion or whatever, will eventually, like, can be made arbitrarily large. That's essentially what we want to do, no? Like, given any if we have some set omega, where the t variables in that set, I mean, they can be negative infinity to infinity even. So we need to make sure that these intervals can be made arbitrarily large. Which I'm not convinced that we can. That is possible. I am not convinced that given Well, you know, I guess we can't do that. No, we can't. We can't do that. I guess that's the question. By Lund love with initial connected t naught x naught, you get a unique solution on some interval. Pick any t1 I naught. You already know the value x of t1. Now apply the theorem again with the initial condition. It guarantees a unique solution on some interval around t1. Why the intervals overlap? By construction, t1 is in I0. Since I1 is an open interval or an open neighborhood of t1, there exists an epsilon neighborhood that is inside 1, but because t1 was chosen inside I0, some part of also lies inside. Wait, let me just okay, yeah, it's not disjoint, obviously. Both solutions x0 of t and x1 of t in I1 solve the same ODE, and both take the same value at t1. By uniqueness, they must coincide wherever they are both defined. Yeah. Therefore you can glue which strictly contains bruh. Hello Asker, hopefully you're doing well. Your study computer, is it also your video game computer, so to speak? If you play video games, how do you disregard the quote-unquote lust to play video games or look social media? I mean, usually, like, I study during streams, or I study at school, or like at university. And in either two circumstances, I'm usually not on my phone. I mean, when I'm streaming, it's you're not on your phone, and when I'm at uni, I find it I don't know, not like appropriate to have my phone whilst I'm in like a library or something like this. And I do play video games on this computer, but usually when I'm on this computer and studying, I'm also streaming, so I'm not doing it. So yeah. Okay. Man, I'm struggling here. Okay, I guess this is the mathematical experience.
I gotta embrace it. But it is possible to me to go on some on your computer, or go watch YouTube videos, for example. Social media on your computer. Like when I'm streaming, I don't do it. Like it doesn't make sense. But with like in the library, I guess it is very much possible. Yeah. But I don't know. For me, I just I'm usually with friends or stuff like that. But yeah. This looks like calculus, but I have never taken. Are you trying to measure the area of the whole odd star shape? No, that's not what we're doing. I mean, if I to try to explain it, we have an ordinary differential equation given by f, and in some interval omega, where at every point it's Lipschitz, we can apparently extend. Okay, so at every point it's Lipschitz, meaning that it has a unique solution. Apparently, we can extend this so that in the entire interval omega, we have a unique solution. And I am not convinced about this. I've probably spent, how long? Maybe 30 minutes on this. Okay, let's see if I can crack this. To be fair, I'll probably do this and then I'll end the stream. I'm feeling fairly tired. I'll probably take like some break, and then I'll maybe do like a study with me stream. Yeah, in a couple hours. Hi. How long will you be live? Yeah, so maybe 20 minutes or something once I understand this. Or who knows? Maybe we'll take the entire day to understand this. I don't think so though, but let's see. So apparently ChatGPT just ignored my question, which is fantastic. Bruh. Okay, if I want to verbalize what my issue is I guess we have some point here. We have the initial condition. We get some interval. We pick another point. Right? We pick like this point. Why the new interval could be inside it. And we can do this again, and the new interval will be inside this one, and again and again. So we're not extending the interval at all. And why is this not the case? Why cannot this be the case? Like what they're arguing is we can pick a point and we can extend it, keep extending it, keep extending it, extend it, and we can get a unique solution everywhere. Do you generally buy stuff from Amazon in Sweden? I notice you have link to Amazon in your description. Yeah, I mean Amazon is fairly convenient. But Amazon is a new thing in Sweden. I think Amazon was released maybe, or was launched in Sweden a couple of years ago, maybe 4 years ago or 5 years ago. I understand that the solution that the new interval overlaps the old one. But why does it extend the original solution? Meaning, yeah. Look at Lipschitz, and basically out of the 4 points it shows on the star shape, you got to find the function that gives you one of the points. We have to find a function that has the initial value at the points, yeah. And we need to make sure it's Lipschitz as well in the entire interval, and therefore it has a unique solution there. You're asking not why they overlap, but why the new interval actually goes beyond the old one. So it's the new extended, so we can truly extend the solution rather than resolving inside the same set. Why it goes beyond the old interval. Thank you. Okay, the original interval, suppose you picked t1 then t1 plus beta is greater than t1. If beta is even moderately large, and it is always positive, then that means the right endpoint of the new interval extends beyond the right end of the original. That means the right endpoint no, man. What are you talking about? Size beta depends on the Lipschitz constant and the domain of f. It doesn't collapse to 0 when you move inside the old interval, so no matter which interior you pick, you always get a non-trivial open interval around it. That interval necessarily extends some distance beyond the original boundary unless you're already at the true limit of the existence. The size beta depends on the Lipschitz constant. Okay. Over alpha, no, alpha over 4 over 6 maybe. assume f is continuous as a Lipschitz condition on a rectangle. Yeah. We'll let Fm be the supremum. Then Picard linear guarantees a unique solution on the interval where alpha is this. Indeed. This I agree. What happens when you move to a new point T1? Now suppose you've already solved up to T1 and you know x of T1. Set up a new rectangle centered at. On that rectangle, you look at the sup M1. Will typically exceed. Then you simply haven't pushed far enough. You can then move closer to the boundary and try again. Eventually either you push past or discover that you reach the true max. This makes no sense. I don't know. It just doesn't make sense. No. No, man. I need math Jesus in my life to explain this. Somewhat. Do I just move on? Just accept my fate? Ugh. Given we are epsilon close to the boundary T0 plus alpha, then the and we call this point T1. Then using Picard-Lindelöf, we can interval. Why can't this interval be like epsilon half? Big.
Mm. How long is the stream? I'm probably, when I understand this maximal solution, I'll probably end it so in like 15 minutes or something. But to be fair, I'm not really sure when this will crack. Ay, ay, ay. Ay, ay, ay. A1 is negative infinity to plus number of in y. Wait, what is y? A1 is going up and to the left, while A2 is going down to the right. If T1 and T0 have the x value is positive, and if T1 I'm not sure what you mean by why. What am I learning? I'm trying to understand the maximal solutions of these. I don't know. Maybe I'll just skip it and ask a lecture tomorrow, or like on Monday. Or maybe I'll even email him. Bro, Isha, I've answered your question. Sorry. Math or physics? It's maths. Yeah. Can only be one solution, or can there be two in the answer? I mean, we only want one unique solution inside omega, right? Yeah, this is kind of okay. I'll just ask a friend who I know is really smart, and and he's taking the same course as me. Oh shit. Messenger. Let's open Messenger. And hopefully he'll respond. Maybe I'll even email the professor if I feel confident. Facebook. Seriously? Can I? No, I can't. Okay. You can use median strategy, where you add up the 2 points I mentioned, A1, A2, and cut it in half to get omega in the middle of the star. Where you add the 2 points I mentioned, A1 and A2. I'm not sure what you mean. Okay, I'll message the friend. I can't log into Messenger on my computer for some reason. Yes. Ay, ay, ay. Yeah. Okay, I'll first want to. Yeah, sorry, I don't understand what you mean, pair. Yeah. Firstly, I want to see if I can share this file with my friend so he knows what I'm reading. Can I do this? La 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 la. La 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 la. Yeah. Yes, save as PDF. Oh. And oh, I did save it. Holy shit, it's 400 megabytes. Damn. Oh, here it is. Oh, hi, Mark. God damn. That is the biggest PDF I've ever seen in my life. Oh my days. Okay, how will I even send this? Can I compress it? Oh yeah, it's high quality. As okay, well. Yay. Maybe I just send the link. So we can get an interval. T minus T naught. An alpha. Okay, so we have a unique solution there.
All right. There you go. I don't think there is an exact answer for omega. It's probably going to be a limit because x is infinity or negative infinity if you go right or left on the line. Join your Discord. Nice. But anyways, I think I'm just gonna end it here. I've gone, I don't know. I just feel that I've done enough. So I'll probably do a afternoon stream, and yeah, or not afternoon stream, but rather an evening Start With Me stream. So feel free to join that in like a couple hours if you want to. And yeah, with that being said, I'll just I'll call it a math stream, and tomorrow I'll probably do another one that that is of similar length, where I'll be tackling some other subjects. Probably I'll start with some ODE to try to get ahead a little bit, since I didn't do that much today. And then I'll prepare some things for my exercise classes I'll have for the first year students, and I'll do probably some linear analysis. Okie dokie. Well, I'll see you guys then. I wish you guys a good rest of your day, and yeah, all right, peace.